Hi, everyone. Thanks for making it out this morning. Hope you all had a good breakfast. So we're going to be talking today about building AI agents with Kiro, MCP, and AgentCore. So I just want to see a show of hands. Who has used AgentCore? Okay, a few of you. Who has used Kiro? Okay, a lot more. And who has used like MCP servers? Okay, that's probably the most out of everyone here. So this is a 300 level talk. We have our laptop set up over here, so we're going to deep dive into some code later. But first we're going to give a presentation. And then I'm going to leave plenty of time at the end for any of you to ask questions. I have a microphone here, and we'll go around, we'll run around and get your questions answered. I'm going to start a few minutes early, too, just because this is a full house and we have so much to get to. You can see here is our agenda. Kind of went over it a little bit already, but we're going to start with what are AI agents? Just a little refresher for some of you who haven't seen this before. Then we're going to deep dive into AgentCore, which I'm really excited about. Did anybody see Matt Garman's talk and mention some of the new, even more features for AgentCore, which I think is awesome that we're continuously adding, getting feedback from the community and adding more things to AgentCore. So we're going to go talk about that and all the different pieces of it. We're going to look at Kiro and how that works, especially with AgentCore. We're going to touch on MCP, and then we're going to spend the rest of the time looking at a demo. And I'm going to show you an example of an architecture you can use to build agents, and then how you can use that with AgentCore. Before I get too far, though, I just want to introduce myself. I'm Eric Hanchen. I'm a senior developer advocate with AWS. And Dewan?
Yes, my name is Dewan Lightfoot. I'm a developer advocate at AWS, focused on agentic AI.
Now, this talk today is really meant to show you how to create agents with all of these different tools on AWS. So my goal is by the end of today that all of you can go back and try these tools out and start building agents today. So we're going to go through some definitions and how these tools all work together. And they do really work together very well to make it much simpler, much more straightforward to build agents. So let's start with some definitions. I'm going to hand it off to Dewan, who's going to deep dive into agents.
Awesome. Thank you, Eric. Hello, everyone. So we're going to talk about what are AI agents. How many of you are building agents today? Oh, a couple people. All right, that goes in line with the AgentCore talk. So by the end of this, hopefully you all are up to speed to understand what agents are, how to build an agent, how to deploy it on AWS. So there are many definitions when it comes to what are agents, but we're going to start with level setting from an AWS perspective. Agents are an autonomous system that leverages AI to reason, plan, and take actions to achieve goals on behalf of humans. Now, when we think about that, there are some key things I want to point out. Reason, take actions, plan. Models are getting better. So when you think of an agent, they're leveraging the reasoning capabilities of a model. The second thing is software systems. Many of you may be developers, architects, engineers, and so when we start talking building agents, agents still need compute, agents still need storage, agents still need databases. So all of the knowledge that you have is still valuable up until this point and beyond. Now, there's been an evolution. November 2022, ChatGPT changed the world, which is why this room is filled now, because all of us are feeling the effects of AI. Now, I started my journey with generative AI in January 2023. I was working at AWS, and I had this challenge of a whole bunch of information I need to stay up to date and stay current with. So I said, you know what? I'm going to start summarizing the blogs so I can stay current and more efficient in my role. Well, at that time, context windows were about 8,192 tokens, right? So you couldn't fit a whole blog into a chatbot or ChatGPT. So what I decided to do was chunk that information summarize each chunk, and then concatenate the chunks, and then summarize that to have one concise summary of the blog, right? That was before RAG. Come to summer, everyone's talking about RAG. Come the end of 2024, now LLMs have tool calling and function calling, right? And now people start talking about agents. 2024, now we have agentic frameworks that makes building agents a lot more simpler. Now we can maintain memory, that context, which we'll talk about here in a moment, and we can build agents a lot more efficiently. We're even at the point now where we're talking about building multi-agent systems, right, and fully autonomous agents. Is that possible? Yes, they're being implemented today. So taking a step back, since all of us aren't building agents, what is an agent? Well, you see that agent, that's code, right? At the center of it is the intelligence, the LLM. And then from there, you give that LLM access to APIs, tools, to be able to look up the weather, look up the date, retrieve information from a database. And then you give it access to memory, short-term and long-term. You need to maintain the conversations and the state, right, of each session. And then from there, you need to be able to retrieve things like historical facts over those conversations throughout the sessions. And this is what makes up an agent, right? But again, this goes back to software, right? How many of you are developers or write code? Right, all of that knowledge that you have is still important when you're building agents today. So how do we take the agents that we're building and deploy them? Well, there's some challenges around that. First, how do you deploy an agent securely, right, in its own isolated runtime? How do you maintain context, memory, short-term, long-term? How do you identify who can access the agent, as well as what the agent can access? You know, that machine-to-machine communication. And then from there, you need to manage the tools that it can use, have some policies and controls around that, be able to discover those tools, and then observe the whole entire system, observability. We call these challenges undifferentiated heavy lifting at AWS. And so to solve this, we introduced AgentCore. And I'm gonna go through AgentCore, then we're gonna hop in some code, but at a high level, let's take a look at that. So you have runtime. When you build your agents, you can use any framework, whether you're using LangGraph, LangChain, Strands agents, Cloud agents, SDK, whatever framework you're using, whatever model you're using, you can take that agent, launch it in the runtime. The thing about runtime, it also supports MCP. So if you're building your own MCP servers, you can launch those in the runtime as well. Runtime supports workloads up to 8 hours, right? Of course, you can build an agent and launch it in the EC2, but then that's always running, right? So this is serverless. So now the agent is only running when it's needed. When it comes to runtime, your agent needs access to memory. So we have memory for that short-term, long-term. Identity, who can access the agent, what the agent can access. Gateways, if you have existing APIs, whether they're open API schema or Smithy, or you have Lambda functions, you can use Gateway to create MCPs for those tools. And then you can wrap a policy, which was announced here at reInvent, around those tools and what those tools can actually do. So now you can put some more guardrails and controls around your agents so they can't just explore the world and do whatever they want to do, right? We have browser to be able to search the web, code interpreter to have this secure, isolated environment to offload code execution, right? You may have some compute-intensive workloads, and rather than having the resources taken up inside of your agent's runtime, you can offload that to code interpreter. And then from there, you have full observability with GenAI observability inside of CloudWatch, but this also exports to OTel. So if you're using something like LangFuse or Datadog, you can export that there. And then finally, we have evaluations. One of the things about building an agent, when you build your agent, start with a use case. Start small, right? After you have the use case, you're building your agent. Next thing you need to do, build observability in from the beginning. So that way you can measure things like metrics, latency, tool use, tool cost, all of these things from the beginning, because the larger your agent gets, the harder that becomes, right? And then evaluations. How well is your agent performing? That's just some things I wanted to cover before we hop into the code. Kind of going through, I'm gonna go real fast so we can hop into the code. AgentCore runtime, I mentioned this already, supports any model, supports any framework. There's two ways to deploy, either a Docker container, we can use the AgentCore starter kit, a few lines of code, get your agent into the runtime, or you can use a zip file. So if many of you are using Lambda, pretty much kind of the same approach. For AgentCore memory, I mentioned it supports short-term and long-term memory. So the short-term memory is for those chat messages, right, in the user state. Now the thing about this, the cool thing about AgentCore memory is that once you have your memory in the short-term memory, now we automatically extract information. You can create something called a strategy, whether it's semantic search, user preferences, summary, or some type of custom strategy, right? I have an example where I wanted the agent to remember the blogs that I searched. So I created a custom strategy around that. So now when the agent stores those short-term memories, it's able to extract using the automated extraction, the information, and store it in long-term memory. So now across sessions, when I talk to the agent or you invoke the agent, it can retrieve that information and bring it into context and perform the task more efficiently. Next, when we come to gateway, I broke this down already, but what this does is allow you to have an authenticated connection to your MCP servers. So if we look at this, if you're using existing APIs now, I mentioned Open API as well as Smithy. You can integrate those directly with AgentCore Gateway. And then Lambda functions. If you have those, you want to expose those as MCP servers, you can put those behind a gateway, and then they can be exposed as MCP servers. Now, auth. With identity, now you can have identity for outbound connections. Let's say you need to use a third-party provider to access some API or JWT tokens. You can use that with Gateway and connect to those third-party APIs right through Gateway. Taking it one step further, I know I've seen a lot of hands go up with MCP. And I am a fan of MCP, but there's some challenges with that, right? When you're leveraging MCP servers, you are essentially giving a whole bunch of information and tokens to your agents, which can, one, make it slower, confuse it, and be extremely expensive, right? So to cut down on that, AgentCore Gateway offers something called semantic search. So rather than just giving all of your tools to the agent, you can use semantic search, and now your agent only gets access to the tools it needs when it needs it, right? So this is a way to save on speed, save on cost, as well as optimize on performance. Finally, something we'll cover at the end after Eric goes to the code, but we're going to talk about observability. Observability is important. I mentioned after you have your use case, the first thing you should think about, or the next thing you should think about, is going to be observability. Monitoring the sessions, the metrics, the latency, the token use, all of this needs to happen from the beginning so you can really understand how your agent is performing and be able to evaluate and optimize continuously, right? So that completes my portion of the session. I'm going to give it over to Eric, and he'll take it from there.
Thanks, Dewan.
Yeah.
Yeah, let's talk a little bit about Kiro and how this can help us today. So Kiro is our new agentic IDE. We released it into preview a few months ago, and it just went into general availability a few weeks ago. I'm really excited. This journey on Kiro has been amazing. When we launched it into preview 3 or 4 months ago, the amount of downloads and the amount of people just loving it and giving us feedback was amazing. We had hundreds of thousands of downloads in the first few days, and we had to put up a wait list, and then people found a way around the wait list. Then we had to have another wait list. But right now, it's definitely generally available, and you can try it out. And it's a really great way to build your agents, because it has a lot of features that make it simpler to build, not just agents, but practically anything. We didn't make this AWS Kiro or Amazon Bedrock Kiro. This is just Kiro. So we really wanted to separate it from the AWS brand in some ways and just make sure that anyone can use it. You can even use social login, don't need an AWS account. But I think it really pairs well with what we're showing off today. That little ghost there that's bouncing up and down, that's kind of the mascot that we went with. So why would you want to use this versus any other of our agentic IDEs out there is we really built in the spec-driven development part of it. So as I was building the demo for all of you today that I'll be showing off in a little bit, I used both of these modes, vibe mode and spec mode. Spec mode, if you don't know, is a way that you can create your, you basically tell the large language model the requirements that you want, and it helps build a requirements document, a design document, and a task list from it. And it's a way you can go back and forth with your IDE to make sure it builds exactly what you want. And we found that it's much more accurate, and it's much quicker. It saves you time when you build it using spec mode, although vibe mode works great as well. Dewan, how would you describe the difference between vibe and spec?
So when it comes to vibe and spec, think of spec as you being an architect, creating a high-level validated design that the agent will follow to complete a goal. When it comes to vibe coding, you just want it to go through, figure out what the problem is, and solve it. You don't really need to have specs around that. Just do what I ask you to do, right? That's the way I kind of approach the two.
Well said. You can also just jump into features in depth with spec mode. We'll take a look at what that looks like in a moment. Going back, and I saw most people raise their hands about MCP. We have a Kiro, since it's an agentic IDE, it does allow you to add in an MCP server, and this works with local or remote MCP. And in fact, today we just launched Kiro Powers, which is a way to add in not just an MCP server, but steering files and more context. So I'd highly recommend everyone check that out. If you're interested in Kiro, Kiro Powers is out today. And we had launched with a bunch of partners, and one partner we launched with is AgentCore. So you can actually go to one of Kiro.dev. There'll be an AgentCore Kiro Power. You can click on it. You have to have the latest version of our IDE, and it'll install it, and it makes working with agents even easier. In the demo, I will show you quickly. We'll move to that website just to take a look at it. Since it just came out today, I'm not going to go through it, but I'll show you guys what it looks like if you want to use it today while you're building agents. We are going to be using, however, the AgentCore MCP server. I don't know if you know that AWS has lots of different MCP servers for all different scenarios. We have a general documentation MCP server, but we have one specifically for AgentCore, just to make it your LLM a little bit smarter to grab and to create agents. Of course, that works with not just Kiro, but any Cursor, Windsurf, whatever else you're using. All right, so let's get started. Before I jump into the code, I just want to give a high-level diagram, architecture of what we're building today. Kind of encompassing this whole diagram is observability. So we are going to look at that with Dewan's help. We're going to have a front end, and that front end is going to connect to our food tracker agent. And this is, so we kind of I built this multi-layered just to emphasize that you can have agents talk to other agents. In this case, we have our recipe agent, which is also an MCP server. That's that middle box there. And that's more of our orchestrator. It's going to talk to two MCP servers. One is the recipe server MCP. The recipe server talks to a list of recipes. I'll show you what that looks like. It can retrieve them. It has a number of tools. I also have nutrition ingredients. So that has a list of ingredients. And that's using our gateway, using Amazon Bedrock AgentCore gateway. I know it's a mouthful. I'm not using any semantic search like Dewan just mentioned, but I could have certainly added that in there. I only have a few tools in our nutrition ingredients MCP server. But you can imagine, to reiterate what Dewan was saying, if you have like hundreds of tools in your MCP server, those get added in and take up tokens. And your agent or your LLM, it'll have to process those. And so it is a little bit of a problem with MCP servers. And semantic search certainly helps fix that. Here is another diagram. I know this is a lot of boxes, and it's kind of probably hard to see. But let me explain what we're doing here. We're going from the user which is you at the keyboard. You're going to be talking to a front end. In this case, I'm a big React and Vue.js fan. Any Vue or React fans here? Any front-end devs? OK, a few. Then that's going to talk directly to our food tracker agent. And that food tracker agent, it's really meant to be the gateway to talk to the front end. So it talks in a very friendly, natural way to the front end. And then it talks directly to the recipe agent server, which really takes, it's an agent, but it just kind of formats what it receives from the MCP service in a certain way. So you can think of the recipe agent as more of an orchestrator. And then, of course, we have Amazon Bedrock. We're using some Anthropic models and Nova models. And then the last box there, it says recipe server MCP, gateway MCP. Those are two actual servers, but I didn't have enough space on the diagram to make it more longer than it is. And you can see a little bit with these arrows kind of going back and forth of how the flow is. So before we get to that, let's jump into the demo.
While Eric is setting up, do we have any questions about anything we presented? Any questions? No questions? We do have one. OK. I'll take two. I'll get her, then I'll get you. If you all can pass that down, please. Thank you.
So I have been using QCLI.
Yes.
In the VS Code extension. So what is the difference between now you have renamed the to Kiro CLI, right? So what is the difference between the Kiro IDE and this extension? Are there any added advantages like using the separate IDE?
Yeah, that's a good question. So you're asking if there's differences between using Kiro, the IDE, and maybe use Q IDE in the past, or QCLI?
QCLI in VS Code.
Yes, QCLI. So QCLI, we changed the name. If you do an update on QCLI, it becomes Kiro CLI. So that's kind of the biggest thing. Although if you do not want to change, you can continue to use QCLI and turn off your automatic updates. Q isn't going away, but we really are focusing on Kiro, the IDE, Kiro CLI. We see a lot of advantages with the two together. If you may have noticed too, Transform has now been kind of pushed into its own service. So if you're using that with Q, you can now use it without Q as well.
Thank you.
Mm-hmm. And we could talk offline. A lot of you may use like Cloud Code. Some of you may use Cursor. Some may use Kiro. I think there's two different like workflows, like one operating in the terminal, one operating in the IDE. I think it's a preference at that point, but there's also I find developers like the IDE, but then people that are like in operations prefer like the terminal because it's right there. So if you all want to talk more about that, I'd love those type of conversations. We can talk after.
How do we set up like long-term and short-term memory in AgentCore? Like, can we define what is long-term and what is short-term? And if we are setting up long-term variables, like do they use more tokens? Does the agent use more tokens to retrieve those?
So there's a couple ways to do that. So when it comes to setting up your agent, you can just set up short-term memory, right? Or you can have long-term memory. But let's say you're using the starter kit. When you launch it, you can tell it then to do the short-term memory, and then it'll automatically do the long-term memory, right? But you can configure the long-term memory to have different strategies. So that's the most important thing, is the strategies that you want. Do you care about just a summary of the conversation? Do you care about user preferences? Do you care about facts from the conversation? And so those are the strategies you will set up for the long-term memory. And you can do that through Boto3. You can set up the strategies and the memory with CDK. That's how you can set it up. But if you want actual code, I can get you code. All right, awesome. Thank you for your questions. Go ahead, Eric.
Awesome, thank you, great questions. We'll have more time to answer more at the end. I wanted to give you guys plenty of time. So I have Kiro open here. So let me give you a quick tour of Kiro and how this works, because I saw not as many hands on the Kiro side. So this is the IDE. It's based off of VS Code. So those who know and love VS Code will be right at home here. On the left-hand side, we have this little ghost icon. And this is where we can do very Kiro things inside here. So we can add in agent hooks. So these are ways that you can have agents run in the Kiro IDE on certain actions. For example, maybe you save a file that it updates your documentation. We even have a little example of doing that. Or maybe you wanted to do some localization. And you can also have it on delete and a few other actions as well. Then we have our steering files. These are like rules files in other IDEs, so you can set exactly these will be added to the context, and then you can tell it, if you're using AgentCore, do XYZ. In case I actually created an AgentCore steering file. So this is what I did is I told Kiro, and someone mentioned Kiro CLI. We can use even Kiro CLI to create a file with the best practices of using AgentCore. So I have an AgentCore Gateway CDK best practice file that I created with Kiro and then added it into the context so that way anytime we're doing stuff with CDK, it looks at that file. And then what you can do on any kind of new project when you open it up in Kiro, you can tell it to generate the Kiro steering files. Kind of looks like this. You can either do it through the menu, generate project steering files, or if you're in a brand new project, there's a button here. And so I did that with this project, and this kind of just tells it exactly what's already existing. So you have an existing project, you can create the steering files, and then they'll be added into the context every time you use it. I hinted at this. I can't get into this too much. This probably could take the whole hour, but here's the Spectre of a development flow. It creates a requirements document in this what we call ears format, and it has the introduction, glossary, requirements, and it has acceptance criteria. And if I would like, I could go through each one of these to the design, to the task list, and have Kiro actually build my app for me. In this case, I used it a little bit, and then I went back to vibe coding. So I kind of went back and forth. And then finally, this is the MCP. I have 4 MCP servers running here. I like Contact 7. Quick tip, if you are just trying to use MCP servers for the first time, this is a great one because it has hundreds of different docs in it, and it'll look at those docs before it gets information for you. There's also a AWS documentation MCP server. This is kind of the overall one that a lot of people use because it's kind of the biggest one. It has all our docs in it, and it includes some GitHub repositories. This is the one I would recommend for everyone to use if you're building with AgentCore. Like I said, you don't have to use Kiro with this, but just these are MCP servers. Use the Bedrock AgentCore MCP server. That way you can kind of go back and forth with it as you're building your apps. And then I use Brave Search, that way you can search the web easier. Do you have anything to add, Duan, on those?
Yeah, something I want to call out. How many of you use a coding assistant or coding agent like Kiro? Okay, so what he's showing you, this Kiro tool is agentic. And so by adding the MCP servers, you give it access to additional information. So while he's writing code for AWS to build his application, the agent can write the code, but now rather than it making up an abstraction or the wrong way to implement a function or a class, now it can use the MCP servers to pull in the proper way to write the code. Does that make sense? All right, and so Kiro is a great tool for that. Now, he has a whole bunch of MCP servers. One thing I do want to call out is when you're building your own agents, you don't want to give it that many MCP servers. I like to build specialized agents. Like, give it the tools that it needs so it can complete the task, and as it needs to complete more tasks, then you give it those tools that it needs. Because again, the more tools in MCP servers and tokens that it uses, the more expensive and the longer it takes to process or generate a response. Go ahead.
Good point, good point. Yeah, definitely this is a little bit more of an advanced example. Here is also that vibe and spec coding that I was talking about, where you can just talk to the chat. You can also, it's multimodal, you can put in pictures, all sorts of great information in there. I'm just gonna close this little window here on the side so we can start looking at the code. Sound like we have a lot of developers here. I'm sure you guys wanna take a look. So here I have it broken down inside Kiro here between my back end and front end. This is the Vue app here. And then I have infra, and we'll look at that in a second. I'm using CDK. I think the best thing to do is we can start with the recipe server. So let's take a look at that. I'm using Python. I'd recommend, if you're using AgentCore right now, to use Python. I think it's the most simplest to use. This is very simple. So we're using fast MCP. This is a pretty popular MCP library that you can use on Python. And then I'm setting up tools. And tools are kind of the bread and butter of MCP. I mean, there's other things like elicitations and a whole bunch of other things, and we'll take a look at that. But this is kind of the way you do it. What I'm doing here is, to keep this simple, I have a JSON file with a bunch of recipes in it. And each recipe has ingredients, of course, instructions, how many calories it has. And then I'm exposing through the recipe server some nice tools to grab that information. You can imagine if this was in a production, that JSON file might be in RDS or somewhere else, an S3 bucket. Or however, though, just for the simple example, it's just hard on the file, hard-coded on the file. And in an AgentCore, when it's deployed, it's actually in the container. So here it is. I have recipes by difficulty, get quick recipes. One thing I like to do when I'm working with agents is I would like to use the model context protocol inspector. So I'm going to go to my recipe server. And I'm a big fan of UV, so we're going to use UV. And I'm going to use run recipe. And so now it created a new MCP server so I can test this locally on port 8000. And I'm just going to go back up to my command here. This is an npx command to run the inspector. This is an open source tool that the MCP Foundation has given us to test MCP servers. So here it is. This is what it looks like. I'm using 17.2. I'm using streamable HTTP, which is because it is running on a server locally. I'm going to click connect. And here's all the different ways you can work with an MCP server. You have resources, prompts, tools, ping. Obviously, we're going to use tools. And here's the ones that we just saw that in file. The get recipes by type, get recipes by cuisine. Let's try it. Let's try, in this case, we're going to say pasta. So it's going to get all the pasta recipes and output it into this schema that I defined. So really quick, here it is, classic spaghetti carbonara. Beef stroganoff. So here is the list. So definitely working. I always like, when I'm working with agents and MCP servers, I always like to test locally first to make sure it's working. This is a great tool to do that. OK, so now we see what the server is. Remember in that previous slide, it was those two MCP servers. This is the one that's run by runtime AgentCore. So I'm going to Control-C it.
Eric.
Yep.
I know a lot of you all are using MCP servers. How many are building MCP servers? Okay. So do you understand? Let's take a step back. When it comes to what Eric is showing you, he's showing you how to build an MCP server, right? That tool decorator that goes over the Python function, that lets the agent or the LLM know that this is a tool from the MCP server, right? The type lets it know the parameters that should be passed in, and then the doc string is actually what goes to an agent. So when we talk about, or the LLM, so when we talk about increasing the amount of tokens, all of this is created in a JSON schema that goes to an LLM. So in order for an agent to know how to use that tool, you need a clearly defined doc string inside of your function. And oftentimes, if you just install an MCP server, sometimes they load a whole bunch of information, and it could be a whole lot of tools, and all of those tokens are processed every time you invoke the LLM, right? He did it really efficient and this is a kind of simplified version of an agent, so it's easy for the agent to understand. But the more tools you have, the more information you'll need in that doc string. And so what he showed you is how to build the MCP server and then use the inspector to test it out locally before you actually deploy it.
Let me show you the Lambda gateway real quick. So this is a normal Lambda function. That was, I have a handler, have events coming in. Imagine this, you just deployed this to Lambda, and now you want to make this into an MCP server. So it looks for food and a JSON object and also serving size. And so this returns a list of ingredients. And then I just have a quick lookup. I also have another JSON file here, this nutrition JSON file. And I have a few commented out code. You could tell this is a demo. And then it just returns a JSON object back. So this is really nice that Dewan was talking about before. If we have existing infra and we want to convert it over to MCP, we can do it. And you're probably thinking, is this just magic? We just like point it to this and it kind of just turns it? Well, no, there is another step you have to do. In my infra, I have a lib folder and then I have a infra stack. And inside here is where I defined my AgentCore gateway. Right here, this food tracker gateway. I have to obviously put the name. There's some auth. We'll talk about that in a second. And then right down here, I define a schema. And this schema tells basically AgentCore how this Lambda function is. And this is saying, by the way, we have a properties for food and serving size. Those are the two events that go into that Lambda. And we just define it as a string. This is a number. This is an object. So that way, it knows how to work with the MCP server. It basically creates it using this way. I was going to ask Dewan, I haven't mentioned this, but everything that's deployed to AgentCore runtime is backed by IAM, or you can have it backed by like Cognito using OAuth too. Do you have anything to add to that, Dewan?
Yeah, so the runtime, it's a public service, right? So if you're trying to connect to it, you can use Cognito, extract the JWT token, and connect to the runtime, right? You also can use third-party providers with like OAuth. You can set that up through identity. So that access inbound to the agent, but then outbound as well from like the gateway. If the gateway needs to access third-party APIs, you can use AgentCore identity to set all that up to provide the agent with all the authentication it needs to be able to connect to those tools.
And we do have an L2 construct with AgentCore Gateway for you CDK fans out there. And of course, all our libraries, you can easily connect to AgentCore. I wanted to show you the recipe agent now. So this is the orchestration tool that talks.
We got a question, Eric.
Oh, sure.
Just a small one, right? Like, so in case we are exposing Lambda function via gateway, what is the tool name? Like, what tools does it expose? How do I know?
Oh, that's what you listed before in the schema.
Yeah, this schema here describes the tool name and the tool definition, the properties of each one. And it automatically creates a set of tools. And I'll show you what that looks like based on this. And you can even be more granular than I did here.
Okay, got it.
Yep. Any other questions before we move on?
So this recipe agent, oh, sorry.
Okay.
All right, so yeah, this recipe agent is going to talk to those two MCP servers. I have a number of tools in here that do things. So this is MCP server and agent together. So it's going to take a little bit longer to run. But I have I have this system prompt that it's a nutritional code. So it's going to filter these different tools out. I have different system prompts depending on which tool you talk to. I think the best way to show this is just to run it. And let's take a look at it instead of you guys looking at the code. So we're going to do, I'm in the recipe agent. I'm going to UV run the recipe agent. And since this is also an MCP tool, it should give us port 8000, which means I can run my inspector again, take a look at it, and I'll connect to it. And this time, if I go to tools and list tools, you can see I have lookup ingredient nutrition, analyze recipe nutrition, create weekly meal prep. So this is all the tools that are exposed. These 4 tools, it's basically taking all the tools that came from those 2 MCP servers, and it's distilling it down to these like 4 higher level ones that you can do. So I can look up ingredient nutrition. Let's try that, pancetta. Serving size run tool, and this is going to take a little bit longer. But if I look here, I'm running it locally, you can see it's calling the Bedrock Gateway AgentCore that we just created. Actually, I have this deployed on AgentCore, not just running locally. It found 2 tools, this AWS, Amazon Bedrock AgentCore search, nutrition lookup, get nutrition info. And now it's invoking the agent and getting that information back. So it determined that I needed to use the nutrition lookup get nutrition info tool. That's what we saw in that previous MCP server. It looks like it retrieved it. So now it's using its model to kind of update it and format it for us to display. Let me see if it's done. It's still running. So taking a little extra second here to run. So let's take a look at the tool call while it's running. If I go back to the recipe or the nutrition, and we look back at the nutrition Python file, this is the different tool calls. Well, we have find nutrition info, find similar food. So the one it called was, here it is, it finished, was nutrition lookup. Oops. So this one right here, nutrition lookup function. So it's basically using this with these tools in the, well, basically this is a Lambda function. It was able to convert them into tools, and it ran this nutrition lookup based on that schema we saw. So let's see if we come back over here. Here it is, success. So here's pancetta, and now it kind of gave me detailed information about it. Pancetta is a cured Italian meat product made from pork belly. Great.
Now, this did take a little while, right? We're building an agent. It's not a chatbot. You know, agents, when they run, are designed to take a little longer. Like if you use OpenAI's ChatGPT and you do deep research, that could take up to 15, 20 minutes, and it runs like in the background and notifies you when you're done. So when you think about AgentCore runtime, it's designed to support workloads up to 8 hours. So if you're building a deep research agent, this is the type of platform you would deploy it to. So that way, when you need something like deep research or some deep analysis or some agentic function to occur, runtime can handle that, complete the task, and then that session is done. It's ephemeral, right?
Let's take a look at the food tracker. This is the agent on top of everything else. It calls the recipe agent that calls those two MCP servers. It's called NutriTracker. So it's a friendly nutrition and meal plan assistant. This is the system prompt that I passed in. It's using Anthropic, I think 3.7, I think it's right here, Anthropic 3.7. It's also using a few other tools. It's using our Strands agent, which is an open source tool that AWS released to help create agents. Like Dewan said earlier, you don't have to use Strands. It works with pretty much every other agent framework. I'm also using the Bedrock AgentCore library to put this all together. All those other ones were MCP servers. This is going to be the main entry point. And I'm instantiating it here with this app, with this Bedrock AgentCore app. And then I have some environmental variables, some definitions of where to find everything. And if I scroll all the way to the bottom, it's essentially connecting to everything. It has to use this machine-to-machine client authentication because we're talking to it's already deployed. It needs to talk to the recipe agent MCP server. I think the best way to show you this is just to jump into the demo on the front end at this time. So I can't get to the front end from the back end. Let's go to the front end. And I'm just going to run dev on this. So I'm running in port 5173. OK, so here's the health agent with authentication. One thing I want to show real quick is that we actually are using memory. I think someone asked a memory question earlier. So this is using short-term memory. It looks like this. This is how you set it up. This agent memory core config is part of our Strands agents library. We're telling it this retrieval. Do you want to talk about this for a second, Dewan?
Yeah, so this is the AgentCore memory configuration. And so if you see where it says retrieval config, that's where we're extracting from the long-term memory, right? The short-term memory is going to retrieve all the conversation, the session information, right? The user assistant messages along with tool calls and the state. That's short-term memory. But if we want to extract the user preferences or facts about the conversations and interactions, that's what we're actually using the semantic search to extract from that long-term memory. And you can see that listed here. That's the actual implementation of the memory abstraction config. And so we set up the memory config, and then we pass that into the agent. So if you look at the session manager, We pass that into the session manager of the agent. So now when the agent has conversations during that event loop, if you know Strands agents uses something called the event loop. Normally when you build a chatbot or some type of integration with an agent, you have a user message, system message, assistant response, tool calls, tool results. All of that needs to be managed when you write that code. The Strands agent actually handles that through the event loop, right? And so in there where that conversation management or that session management is being stored in the session manager. Something we don't show here is that that context can get very large. And so we handle the conversation automatically with a conversation manager. There's two approaches. There's a summarization, and then there's a sliding window. Sliding window is the default. So after 20 messages, the older messages in the conversation will be removed. Then we got
I
any
like how
questions?
this all works together with the Strands agents pretty well.
Yes, okay.
I'm logged in here to my health agent app. I'm just going to say hello. And what I like to do is also open my inspect, and then I go to the network tab just to see it working. It's a little slow, just based on the network that we're on and the models we're using just for our demo. But here it is. Hello, Eric. I'm still here, ready to help you with your nutrition or meal planning questions you might have. I actually gave it my name before we started this demo today, but I want to show you just that AgentCore memory working real quickly before we have it kind of do some other things. So I'm going to sign out here. I built this using, this is a Cognito login. This is something called the Authenticator. It's just a real quick boilerplate I added to it to add in a way to log in. And so now I'm logged in here, and I'll say, hello, my name is Eric. And so now this is a new session, basically with a new user. So it should talk back to me as if it was the first time. I was logged in with a different user the first time when I just said hello. And I can see it's running the invocation here. And I can even take a look at the stream. So hello, Eric. It's nice to meet you. How can I help you with your nutrition or meal planning today? So if I log out and I log back in, and I say, what is my name? It should remember that I said it was Eric from this new session that I created here. And then it'll retrieve from that short-term memory what it saw and then bring it back here. And it looks like it's running this invocation here. I always like to kind of play around with it and look at it too to see what it's doing, the response. You can even see.
From long term. It'll be from long term because you signed out, sign back in. When you sign out, that ends that session. When you sign back in, it's a new session. So the user preferences will get stored to the long-term memory, so it should remember his name and bring that back into the conversation. A key thing to call out here, and Eric can show you, is that we designed it so the system prompt knows that whenever the user addresses or has some type of personalized interaction, that it should address you by name. So that way you'll see and have this personalized user experience in your app. So. Yes, so that's all the LLM, but the retrieval, when you saw the memory config, that's actually extracting automatically from the long-term memory and appending it to the prompt. So that way when the prompt goes into the LLM, it has the information it needs to know, okay, the related information related to the name, let me retrieve that, append it to the prompt, and then invoke the model. No problem. I got one back here.
While you're answering questions to one, I asked it, can you create meal prep plan for a week for 1,500 calories or under? So now it's going to use these agents that are connected to it. It's going to go back and forth, run that loop a few times, and return back an answer for me.
Oh,
I have a question here. So basically, this agent memory, whatever system parameters that are in the, like, is there some set of system parameters that it knows to store itself and some kind of customizable parameters, or is just basically all up to how you code it?
Eric, you mind going back to the memory slide real quick?
The memory slide or the memory code?
The memory slide.
Okay.
Yes, is that possible?
Yeah, give me a sec while that's working.
So we'll go back to the memory slide, and I'll show you here what it looks like.
Let's see here. Let's see all the way back here. This is observability, gateway.
I think it's before this one. All right, so here. All right, so when we actually create, you have to create a long-term memory strategy. And so if you look, the short-term memory is the chat conversations, chat messages, the user-assisted messages, and the session state. That's short-term. That can last up to 30 days per session, right? The long-term memory, you have to create these strategies. So you can have a semantic where you extracting semantic search from the actual conversation of the search on memory, the user preferences where things like your name, your birth date is actually being extracted, the summary, episodic, and then you can create custom strategies as well. So you create these with CDK or something, you deploy it inside of memory, and then from there, you have the retrieve memory records. That's a function call, right? That you use to retrieve the records and bring it into context for the agent. Now, the SDK or the AgentCore SDK, when we create the memory config and we added it to the Strands agent, that's handling it, all that for us automatically. But you can use something called an event hook where you can extract this and design it however you want. And Strands agent supports that.
All right, let's jump back to the demo. So here, I asked it a question to find the meal prep. So I was able to take those two MCP servers, use the agents, and come up with a list of our daily meal breakdown. So it said, I'm happy to do weekly meal prep for you, Eric. I'll design a balanced meal with meals total 1,500 calories, and it has each meal breakdown for each day. So I think would be interesting, you're probably thinking like, how did it do this? Let's look at the observability and real quick, and we'll show how it works. So Dewan?
Yes.
Yeah. Can we leave the questions just to the end so we can show this observability?
All right, I'll show that.
Yeah, I think we're just running a little bit out of time.
10 minutes. All right. So I'm gonna hop in and show observability. All right, so the first thing we wanna do is open up AgentCore. Let's see if we can zoom in so we all can see this. Now, inside of the console, and you can get to a lot of this from the terminal, like if you're using the starter kit, you can view a lot of the CloudWatch logs. But a key thing, we'll go into the runtime. And once we're in here, we'll go down to the agent that is running. And we have our food tracker agent. Notice here the versions. So as you launch a new agent or update the agent and launch it into AgentCore, it creates a new version. And that's important to remember because that version will become the default version, right? So the latest version goes to default. So whenever you invoke the agent, now you're invoking the latest version. And so that's something you have to keep in mind. Now, once you're in here, you see the endpoint for that agent. You have the CloudWatch logs and the CloudWatch GenAI observability for the agent. First thing we'll do is go into the logs. The thing I like about the logs is that you can actually go in and look at the log streams. So that shows you, if we go into the latest log stream, what the inputs, what the outputs that will actually happen inside of the agent, right? So if you're getting some type of error, some type of authentication issue, or there's an issue with your code, if you go into the log stream, you can view all of that here, right? Clearly defined, line by line, what's happening in the agent, you can see that. So you can put your print statements. If you use Lambda function and you troubleshoot those, you can pretty much do the same thing with the runtime. Now, the key thing that we all care about is the GenAI observability. And once we're in here, this takes us into the default agent, right? The agent's default, the latest version. And what you'll see, when it comes to GenAI observability, you have the session. Under the session, you have traces, which is beginning to end, right? So if you invoke, the response is one trace. Now, inside of a trace, you have spans. That's every step that happens inside. So if we go into the sessions, we'll click the latest session from when Eric just invoked the agent, and then we'll actually take a look at that.
does take a few moments to load the trace, especially on the network we're on. Sometimes refresh it there.
Yeah, it takes a moment for the Gen AI observability to populate. And so once we have that, what we can actually do is go into the agent and look at, this is the recipe agent that's there. We'll look at all sessions. And we'll click on the latest session. Notice we have 3 traces, so that means he's invoked the agent 3 different times. So we'll go to the most recent one. For this particular agent. And so here we have 3 different traces, and we can look at the average trace latency, which is something I could have called out before. But you can actually see if we go back, and I'll go back because that's important. But inside of here, when you actually look at your agent, you could look at the observability for the agents, the memory, the tools, the gateways, and identity. So what this shows you is not just the information about the agents, but the runtime, the latency, everything that you want to know about the invocation time, the errors, the tokens. You can see all of that when it comes to the agent. And so we'll go in here to all sessions one more time. We'll click on one trace.
I really like this detailed view that it gives you here.
And this is for one of the MCP servers. So you can see here we have the MCP server, and we just have one span inside of here. So we'll have to go back and find the actual agent session. And we can determine that because it's going to be a lot more tokens if we look at that. So if we come in here and go to all sessions, you can see the latency for this one. So we know this actually took a long time, so this had to be a lot of things going on. And there's only 4 different traces. So this took about 44 seconds, and there's 4 different invocations. So what we can actually do is narrow down, wow, look at the latency on this one, and there's 20 spans. So that means there were a lot of tool calls, a lot of things happening from the time that the agent was invoked to the result and the response from the actual model. So we can go into this trace. And once we're in this span, notice that this is another MCP server, but what we can actually do is look at each span as we go down. And we can see, okay, what's taking the most time? All right, we get down here and we see this invocation. This took 53 seconds, right? And we can see everything that happened from the time we invoke to the time that we finish. We can see the inputs, the outputs, and this is a summarized view over here of all the spans that happened, but we can see every event that actually happened, right? All of the telemetry is in here. But if we come into the chat, you can actually see, okay, here's the system message, here's the user message, the assistant message, the tool calls, and you can see all of these JSON inputs and outputs from the model, the agent, and user prompts that were passed in. You can see all of that along with the time, the amount of tokens. As you can see, input tokens here, output tokens. So if you're really trying to analyze and get observability of your agents, you can do that for each trace. We got a question back there.
Okay, let's hold the questions at the end. Do you have anything more?
I think it's a good point to go to questions.
Okay, all right, well, let's get a question in then. We got a question? Okay, we have one.
Yeah, he had one up front. And then
sorry, yeah, go ahead. You can go ahead now.
Okay, my question was, when you were saying that for the agent, if you use the semantic search, it's going to avoid using too many tokens. That's the part when you are getting the memory for the config and getting from the long-term memory and pass it to the agent? Or is a different thing?
So when we talk about using too many tokens, there's a lot of variables in that, right? What you'll have to do is actually look at the observability. And so what this will allow you to do, to look at each span to see how many tokens were used, right? So right now we're in the span for the chat with the agent, and we can see exactly how long this span took, meaning the time we invoked the actual model, the input tokens, how many tokens were passed in, and how many tokens were output. Now what we could actually do is go in here and look at, okay, when it comes to the tokens that were passed in, well, we know the system prompt, how many tokens did that take, right? We can actually look at that. The user message, how many tokens did that take? The tool calls, the tool messages, how many tokens was that? And we can actually analyze and get very granular at that point. That's what we can do in observability.
Okay.
All right.
We got one more in the back.
We only got 2 minutes left.
Okay.
So maybe let's switch it over to then we can answer some questions. Let's switch it over to the PowerPoint. So I just wanted to say, if you need to contact us, our email addresses are here. We'd love to talk to you guys. Thank you so much.